A turbine, a water turbine with water in and out, import and output, that turbine produces electric power. This sort of turbine is used in piping systems and perhaps in the legacy hydroelectric power plants. But this presentation is about static pressure. Static pressure powered turbines to produce electrical power. Now, static pressure is available naturally in the oceans. The ocean depths are in places thousands of meters deep. And the rule of thumb is that for every 50 meter of depth down from the surface, you add 1 atmosphere of pressure. Now, if you go down 500 meters, that would be 50 atmosphere of pressure down there. It will be more than that because the water 50 meters down is supporting the water on top in some sort of equilibrium. So there you have water at 50 atmosphere. What will the temperature of that water be? Right? So now if you have a cylindrical pipe of cross-section area less than 1 meter square, and use the fact that pressure is equal to normal force divided by normal area, which means force and area vectors acting in the perpendicular direction, up and down, or up the y-axis. Such a pipe of 1 meter square, less than 1 meter square, and cross-sectional area will pour the water down from the 500-meter position of the sea up to the surface and up to the Empire State Building roof just by static pressure. Now that static pressure can turn a turbine to produce electricity. Now you can have something like this offshore to provide electricity near to the shore, and near to the shore you heat seawater to 550 degrees Celsius and you put copper chloride in it and you get hydrogen and oxygen out of it. The power that you get from the 500-meter depth offshore, that turbine will heat the water and will also supply land substation. And you basically have fuel-free electricity. You just have to provide the structures and equipment. It should work.